Hello out there on Sunday afternoon. It's Super B Productions working on Sunday for you. Here we go. Getting position time and velocity time graphs straight in your minds. Here we go. The problem is, as you probably can see here, and also I'll read it. Excited about the weekend. Mr. Banks, that's me, left the school for the QT 150 meters away in 50 seconds. He tried to buy 2 bags of chips and realized he left his wallet at the school 100 seconds later. He raced back to the school in 25 seconds. Make a PT table and graph. Make a VT table and graph. Find the 3 slopes and find the area under the curve for displacement. I have drawn some graphs on the board. This will be my position time. In my table, I'll put here. Now it's a good thing to make equal increments. This will be meters, position, time in seconds. At 0, position, of course, was 0 seconds. I traveled 50 seconds, so we'll make it in increments of 25. So at 25 seconds, I was halfway there, which would have been 75 meters. And at 150 meters, I was there at 50 seconds. I stayed there 100 seconds, so that would have been at 150. I was there at 75. At 150, I was there at 100. At 150, I was still there at 125. At 150, I was still there at 150 seconds, which is 100 seconds from when I stopped. And then I quickly returned back to the school, and 25 seconds, which would have been 175 total, I was at 0, back at the school. So now I can make my graph. The time will be in 25-second increments. And then half of that will be right there, which will be 175. Now I can plot my points, 0, 0, 25, and this will be 50, 100, 150. So here I go, 0, 0, 25, 75, 50, 150, and I see this is going to go right in the middle of my table, but that's all right. Then I'm there at 75, I'm there at 100, I'm there at 125, I'm there at 150. So my graph is going to look like that, and then I went home and 25 seconds and I'm back at 0. You can easily see that my displacement is 0 because I started and ended at 0. We're finished with the position time graph. It's just that easy. Make equal increments of time, 25, 50, 75, 100, 125, 150, 175. Make equal increments for position, which is 0, 75, 150, 150, 150, 150, 150, and 0. And I did my graph accordingly. 50, 100, 150, and 75 is halfway, which is right there, and 150 at 50, 105 seconds, at 100 seconds, at 125 seconds, and at 150 seconds. Very nice. Now let's do the velocity time. I'm going to find the slope right here of the position time graph, which is 150 minus 75 over 50 minus 25, which is 75 over 25, which is 3. 3 meters per second. 3 meters per second. 150 meters minus 75 over 50 minus 25 gives me 3 meters per second. So down here, let's make this 0 for my velocity, and that's meters per second. Let's make this time, which is seconds. And now let us do a table. So we can assume, as we said before, at 0, I'm already moving at the velocity. So at 0, we'll do the same time increments. 0, 25, 50, 75, 100, 125, 150, and 175. There we go. So from 0 seconds to 50 seconds, my velocity is 3. 3, 3, 3. At 75 and also at 50, because I immediately stop, it's 0. At 50 seconds, it's 0 meters per second, because I'm going 3 and I come to immediate stop, which is 0. And then I'm at 0 for 75, 0 for 100, 0 for 125, and 0 for 150. At 150 seconds, that's 100 seconds of rest there at the store. I immediately realized I don't have my wallet, and I shoot back to the school in 25 seconds. So we'll find the slope of this part of the graph. We always do on the negative, the one closest to the axis, which is 0 meters minus 150 meters up here. The time here is 175 at 0 seconds, and at here it's 150. So my speed is 150 over 25, which should be 6 meters per second, which is easy to see. It's twice the speed or velocity of that, and this is a negative because I am returning. Negative 150 over 25 is a negative 6 meters per second, as you can see. So now I can do my graph at 0 seconds, at 150 seconds rather. I was also going 6, and I was 6 at 175 when I came back to the school. So now I can do my graph. Here we go. That's 50, 75, 100, 125, 150, 150. Let's make it about even there. I don't have a ruler there. And then that's 175. So I'm 3, 3, 3 for 50, 25, 50. So at 0, I'm going 3. It's just going to be 3 meters per second. 25, I'm going 3. At 50, I'm going 3. I immediately stop. So my graph comes straight down. At 75, I'm 0. At 100, I'm 0. At 125, I'm 0. And let's see, 150, let's make it about here, that's even. 150, I am 0. And then I immediately, at 150, I go immediately to 6. So it comes straight down, all the way to 6, which would be right here, minus 6, minus 3. On my graph, minus 6 will be right there, and I do that for 25 seconds, so I'll be right here. And so my graph, if I connect the dots, make them nice and big so you can see them on the video, make them nice and big. Oh yeah. Oh yeah. Oh yeah, you can't miss those. So, here we go, across here. These are not up there, they're down here. Sorry about that. Sorry about that. That. Like that. There we go. So, for 50 seconds, we go 3 meters per second. We stop for 25, 50, 75, 100 seconds. We immediately go 6 meters per second for 25 seconds. So my graph looks like this. And if we want to find the area under the curve, which is displacement on a velocity time graph, we do this area right here, which is 50 times 50 seconds times 3 meters per second. Seconds is 1, so you have 50 times 3, which is 150 meters, plus 150 meters for the first part of the journey. Now I can do the displacement under the curve here for this return trip. And again, we have 25 seconds times 6, or negative 6 meters per second. Seconds cross off. 25 times 6 is a negative 150 meters. So you can see I want a plus 150 meters. I want a minus 150 meters. So my displacement is 0. Thank you very much for watching. Stay tuned for more. This is Super B Productions signing out.